Back in the day, our solar system was considered to have 9 planets. Scientists have made sure to remind us of this fact with every opportunity they got, and elementary science teachers referred to it in classrooms as much as they could. But everything changed in 2006 when the International Astronomical Union, IAU, decided that Pluto, a strange icy world situated in the depth of space, would no longer be regarded as a planet. But why exactly was this decision made? And if it's not a planet anymore, what then can it be? Join us in this video as we reveal why Pluto is not a planet. The idea of Pluto not being a planet is a hard one to deal with, especially for people who attended elementary school before 2006. But the warning signs were always there for everyone to see. Right from when it was discovered by Clyde Tombaugh at the Lowell Observatory in 1930, we knew it was a strange world. This was some 25 years after Percival Lowell had predicted its existence. As far as we know, it has maintained the same position in space right from when it was discovered up to this very moment. So why then was it reclassified, and what is its new status? To understand the phenomenon and complexities of why Pluto is no longer a planet, we first need to properly define and understand the meaning of planet. Back during the era of Galileo, the word planet was defined as a celestial object that orbits the Sun. Of course, this definition wasn't exactly defining as it were, but scientists sailed with it until in the early 1800s when Ceres, a small celestial object, was discovered. This mysterious planetary body was found to be orbiting the Sun halfway between Mars and Jupiter, the exact location of the asteroid belt. During further observations, they discovered a slew of other space objects initially believed to be planets. However, as scientists continued their observation, they found some similarities between these newly discovered objects. To start with, they were incredibly small and arid. These are two features that are in characteristics of planets. More significantly, they didn't have the shape of a sphere like a normal planet would. So, scientists classified them as asteroids and went back to learning about the 7 planets that existed at the time. The discovery of Neptune in 1846 made it 8 planets, and 84 years later, we found Pluto, which took the total number of planets in our solar system to 9. Upon its discovery, Pluto caused quite a number of fierce debates among scientists and astronomers. From the onset, some had predicted that it would end up like Ceres and the other celestial objects that were discovered along with it. But there were other reported features that suggested that Pluto could well be a planet. For instance, the initial measurements released by scientists put Pluto in the same bracket as Uranus and Neptune in terms of size. 1 year later, that measurement was revised, and scientists posited that Pluto was about the same size of our Earth. In 1984, they adjusted the size yet again, and this sequence would continue until they were eventually able to get its correct measurement in 2006. According to this new measurement, Pluto is believed to be smaller than the Moon and twice as big as Ceres. But despite its small size, astronomers found a moon called Charon, and this sparked debates about whether it is a planet or not. The main argument in favour of Pluto was that if it is a planet, then it surely must be a planet, and that's not exactly the case. Upon close observation, scientists found that the size difference between Charon and Pluto isn't exactly much. Pluto is actually twice the size of Charon. That may sound like a huge difference on paper, but in reality, it's not, especially considering the vast difference in size between some other planets and their moons. As a matter of fact, some scientists have suggested that both planetary objects be classified as a binary system rather than a planet and a satellite. Also, Pluto and Charon are quite similar in mass, such that the Moon distorts Pluto's orbit around the Sun, prompting it to wobble back and forth as it drifts through the vastness of space. This discovery was an eye-opener for scientists who began to actively rethink Pluto's status as a planet. And with every new celestial object discovered beyond Neptune's orbit, the doubts around Pluto's planetary status became a huge topic of debate. But since it had the approval of the IAU, astronomers were careful not to reclassify it in a hurry, especially because the available evidence was contentious. However, the discovery of Eris in 2005 gave us more clarity. Indeed, Eris is a minute-sized celestial object, but in the early days after its discovery, scientists claimed it was many times bigger than its original size. And that brought the debate about Pluto's planetary status back to the front burner. In 2006, the IAU, the organisation responsible for classifying celestial objects, revised the topic, releasing 3 criteria that define if a planetary body is a planet. According to the resolution released by the IAU, for a celestial object or body to be classified as a planet, it must first be in an orbit around the Sun. Secondly, it must have enough mass so that its self-gravity is able to overcome rigid body forces so that it has a hydrostatic equilibrium, nearly round shape. And lastly, it must have enough gravitational force to clear all the debris in its neighbourhood around its orbit. But unfortunately, Pluto only meets 2 of these criteria. The small icy world falls short of being a planet because despite the fact that it has a spherical shape and orbits the Sun, it hasn't cleared the neighbourhood around it. Some argue that our Earth also falls short of this rule because the neighbourhood around it is not cleared, which makes it prone to asteroid attacks. But then, the asteroids that occasionally fall on Earth are not exactly within our neighbourhood. According to astronomers, these rogue celestial objects are visitors from the depth of space, and some of them even coming from outside our solar system. In the end, the resolution stood and Pluto was officially demoted from being a planet. But Pluto still needed to be classified, so the IAU put forward new resolutions to accommodate this strange object. Under the new resolution, the IAA added 2 new categories of astrophysical objects called dwarf objects and small solar system bodies. Dwarf planets also have a set of rules they conform to. Before a celestial object is classified as a dwarf planet, it must have significant mass for its self-gravity to overcome rigid body forces so that it has the shape of a sphere. In addition, a dwarf planet must not be a satellite. And lastly, it would have debris around it because it cannot clear the neighbourhood around its orbit. Given that Pluto has all of this criteria, scientists officially classified it as a dwarf planet. Again, this prompted another round of debate among scientists who believe that the term dwarf planet could be misleading, especially to those who are not exactly familiar with the space industry and its terminologies. Some even argue that since Pluto has a spherical shape, it should qualify as a planet. This would mean discarding the other 2 criteria that define it as a celestial object and qualifies as a planet. On one hand, that makes sense. But on the other hand, beefing the rules that define planets would mean that some other astrophysical elements, like our Moon, would qualify as a planet. If this is implemented, asteroids and a whole bunch of other celestial objects would also qualify as planets, meaning the number of planets in our solar system would shoot up from 8 to about 100,000 or even more. Ironically, the current definition of a planet is also deemed to be incomplete because it does not suffice for rogue planets that do not orbit any star. It also raises the possibility of stars being planets. This would cause even more chaos and automatically increase the number of planets in our universe to tens of millions.